Alright, so today we have the law of sines, ambiguous case. And in this case, we're talking about that side-side angle case, which is also written as ASS. Yes, I realize it's bad, all that kind of stuff. But one thing to keep in mind here is this is a special case. Because since we have to use an arc sine to find a missing side length, as we talked about in 6.1, when you're taking the inverse, we had to cut those inverse functions so that they could actually be functions. The problem is they only give you one, so therefore they only give you one answer. They don't give you both. And so what could happen is when it cuts, it's only giving you one answer, there could be a second one that you have to figure out. It also could not have none for the same reason. And so you have to, whenever you're using law of sines in this situation, you have to check to see if there's multiple solutions. And on the test, I'm not going to tell you specifically to check. You're going to just have to, I'm going to expect that you know to check for a second solution. So let's look at this here. If I draw it out, draw our triangle. A, B, and C. Side length A is 3, side length B is 2, and 40 degrees here. So, in this case, if you're working along, what you'll notice is you have an angle measure opposite of side length, so it's the law of sines. But now we're trying to find this missing angle measure because we don't have anything else but this side length. So we're going to set up the sine of 40 over 3 equals the sine of angle B over 2. We're then going to cross multiply, and you'll get 2 sine of 40 equals 3 sine of beta. So then we divide everything by 3. So you get 2 sine of 40 over 3 equals the sine of beta. Then you're taking the sine inverse of both sides. So take the sine inverse of that. You're taking the sine inverse of that. And we get B to equal 25.4. And hopefully, once we've seen this, since we took a sine inverse, we know to double check here and say, okay, it's a law of sines, and it's an ambiguous case because it goes angle side side, in a consecutive, either clockwise or counterclockwise order. So I know I have to check. So that we're going to call this B sub 1, which means I could have a B sub 2 that could fit inside this triangle, because sine is also positive in quadrant 2. So you could get a second answer where it would be 180 minus 25.4, which would equal 154.6 degrees. Now, at this point, some of you are probably like, why? How do I know if that works, doesn't work? Like, what do I do with that? So what you're going to do with it, the smallest one's always going to work. So this for sure is 25.4. What you have to do is you have to double check to see if the rest of it works. So here, you end up with a second triangle. And within that second triangle, you plug in the 154.6. Now, is this triangle possible? Is what you have to ask yourself next. In this case, you would say no, because this is 40. 154.6, they add up to something way bigger than 180. So therefore, this can't possibly be a triangle. So when you have this situation, then you're just like, okay, well, that's easy, because now all I have to do is I basically scrap that one, and I just continue solving this. So here I can find angle C by subtracting 25.4 from 180, and you would get that angle C comes out to be 114.6. And then I set up the law of sines, again using my newfound angle measure along with my givens. And you would find that C should equal 4.24. So now we have all the side lengths, all the angle measures, and that's it. I will say is that I made note up here, make sure you show the work that you found a second beta, and that it's too big to fit in the triangle, because there are points allotted on this test for you to, or basically wanting you to acknowledge that there is a second angle measure, but it just didn't work. Okay. So, if you're observing, you probably notice here, in this situation, you're going to have two full sets of answers, denoted by the subscripts here and the subscripts there. And so, once again, if you're working this out, how you would know that that's going to happen. So you start off like before, fill in all the given stuff. So that's 6, that's 8, that's 35. So we see this is a law of sines. So then we set up a problem here. We're going, okay, it's also angle side side, so I'm going to have to check for a second solution. So I might as well, I'm going to copy this over, because I want to, there's a possibility of a full second set of answers. So I'm working this out. I have the sine of 35 over 6 equals the sine of beta sub 1 over 8. Cross multiply, solve, and you should get that beta sub 1 will end up equaling 49.4. Or sorry, 49.9. I don't know what's wrong with me. Beta sub 2, however, then will equal 180 minus 49.4. Why did I say 0.4? I'm losing my mind. And that will equal 130.1. Alright, so we get 130.1. So we know the small angle always works, so that's 49.9. Now here, we have to check, is it possible that 130.1 could fit in this triangle? And in this instance, what you'll see is yes. In this case, it does work, because 135 and 130 is 165.1. So there's still enough room to squeeze in that little third angle measure. So then what I would do next, I would find this missing angle measure, because it's the easiest to find. So you're at a 165.1, which means you're looking at a 14.9 for that small angle. And then you would set up the law of cosines using that small angle measure and you're given. So sine of 35 over 6 equals the sine of 14.9 over side length C. And once you solve it, once again, that's C sub 2. Make sure I want to keep up good notation. C sub 2, you should solve and get 2.69. Then we'll go back to our original triangle. So here's your first full set of answers. Now we go back to the original triangle, subtract my two angle measures from 180, and you would get a 95.1 here. And so then you would take the sine of 35 over 6 equal to the sine of 95.1 over side length C sub 1. Simplify, and you would get C sub 1 to equal 10.42. So once it's all worked out, this is what I'm looking for. Make sure you put the subscripts in there because that helps me identify which triangle what goes, each measure and value goes into. Is if I don't know that, I just see a random mess of numbers. I don't really, from a grading perspective, I don't know if you knew what you were doing or not. So here's kind of an idea of what this would look like and why it works the way it does. What you'll notice is here's your two different C values. So what you're looking at is you're looking at a C sub 1 triangle. That would be this one here. And you're looking at a C sub 2 triangle. That's the overall one. And basically the difference is where this little purple leg is. If it's here or if it's swung back and over here. That's what's causing you to end up with your two different solutions. Alright, last but not least, I know this is a long video, but here's the last one. Go ahead and draw it real quick. I'm just going to pause and draw it myself. So here's our triangle. Once again, we have our law of sines, so we have the sine of 40 over 1 equals, let's go with the sine of A here. The sine of alpha over 2. Multiply by 2 to get the sine of alpha by itself. So you have the sine of alpha equals 2 times the sine of 40. Then we're taking the sine inverse. And you get error. So if that's the case, then this is your no solutions. Answer. And basically what that means is that given these actual angle measures, what this triangle would really look like would be something like this, where this is 40 degrees, that's 1. And the problem comes in here where there's no, there's a big gap. Basically, this just isn't a closed shape, and that's why I know that it doesn't work. But here's your homework. Hope it makes sense.